The situation unfolding in deep space has captured the attention of astronomers, astrophysicists, and even the general public, because something extraordinarily unusual is happening with a Manhattan-sized interstellar object known as 3I/Atlas. What first appeared to be a routine celestial discovery has now evolved into a scientific mystery, growing more bizarre each week. When it was initially detected in July, the object immediately stood out due to a strange observational feature. Instead of streaming a tail away from the sun like any ordinary comet, 3I/Atlas displayed what experts describe as an anti-tail. To visualize this, imagine a plume extending in the opposite direction from where a comet's tail should be pointing. This peculiar structure attracted widespread attention, not only because it was irregular, but because it contradicted established principles of how cometary material behaves under solar radiation and solar wind. Scientists naturally questioned how an object entering our solar system from interstellar space could generate such an unconventional plume pattern. As researchers examined the composition of this anti-tail, the mystery deepened even further. Spectral analysis revealed the presence of carbon dioxide, water, cyanide, and, more shockingly, a nickel alloy that is known to be manufactured on Earth. While the presence of common cometary materials like water ice and CO2 seemed normal, the detection of a processed metal alloy ignited debates within the scientific community. Could the readings be contaminated? Could the signals be misinterpreted? Or was this interstellar object made of something entirely different from anything seen before? Some scientists urge caution, reminding the public that misreadings can occur, especially when dealing with far-off objects. Others, more daring, began proposing unconventional theories about the nature of 3I/Atlas. Then came the twist no one expected. Recent observations from Spain's Nordic Optical Telescope revealed that the object has entirely transformed its behavior. The once mysterious anti-tail has vanished, replaced by a standard comet tail pointing directly away from the sun, precisely as physics predicts. This sudden switch stunned observers. Just weeks earlier, 3I/Atlas had acted like a renegade, defying the rules that govern comet dynamics. Now it was behaving like a perfectly ordinary celestial traveler. Scientists had to ask themselves what could cause such a drastic shift in such a short period of time. The established explanation so far revolves around the intense proximity of 3I/Atlas to our Sun. As the object moved closer to the star, it was exposed to a staggering 33 gigawatts of solar energy, an amount powerful enough to dramatically alter the flow of materials being expelled from its surface. According to this interpretation, the tremendous solar heat unfastened accumulated debris, forcing the newly liberated particles to fall behind the object, forming a classic comet tail. From a physical standpoint, this explanation makes sense. Sunlight heats the frozen surface, sublimating ice into gas, which streams outward and carries dust along with it. Under this model, the transition from anti-tail to normal tail might simply reflect natural progression as the object's orientation, velocity, and level of solar exposure changed. However, not everyone believes the conventional explanation tells the whole story. The interstellar nature of 3I/Atlas already makes it an unusual visitor. Only two interstellar bodies, Oumuamua and 2I/Borisov, have previously been confirmed passing through our solar system. Each introduce questions about how objects form in distant planetary systems and what kind of materials might exist beyond our star's domain. With 3I/Atlas now demonstrating behavior even stranger than its predecessors, it was inevitable that more speculative ideas would emerge. Among the most controversial voices entering the conversation is Harvard astrophysicist and astrobiologist Avi Loeb, a researcher widely known for entertaining unconventional possibilities in the search for extraterrestrial technology. Loeb has suggested that 3I/Atlas's early anti-tail could resemble the exhaust of a braking system, similar to the thruster plume of a spacecraft decelerating from high speed. In his view, the transition to a normal comet tail might indicate that the object has completed its deceleration phase and is now moving without artificial propulsion. He emphasizes that if the object were executing controlled maneuvers, something no natural body is known to do, then its strange plume configuration would make sense within the context of engineered technology rather than natural physics. Although Loeb's proposal is speculative and far from accepted by mainstream astronomers, he argues that the scientific community should remain open to the possibility that not all interstellar objects are merely rocks and ice drifting through space. Some could be probes or remnants from advanced civilizations, especially given the immense age and size of our galaxy. His views have sparked debate, with critics arguing that invoking alien technology is unnecessary when natural explanations remain plausible, while supporters believe that extraordinary phenomena deserve consideration from all angles, including technological ones. Regardless of which interpretation one prefers, interest in 3I/Atlas has intensified worldwide. Space agencies from multiple countries have begun coordinating observational efforts to monitor the asteroid as it continues its journey through the solar system. The International Asteroid Warning Network recently added 3I/Atlas to their official target list, a move that underscores both the object's importance and the caution with which agencies approach interstellar visitors. While officials stress that 3I/Atlas poses no threat to Earth, keeping a close watch ensures that changes in trajectory or behavior are analyzed in real time. In addition to ground-based telescopes, powerful instruments like the James Webb Space Telescope (JWST) have directed their attention toward the interstellar traveler. The high-resolution imaging capabilities of JWST allow scientists to capture detailed visual and spectral data that can clarify the object's composition, temperature variations, and structural changes. Early images have already contributed to understanding its shifting tail patterns, but researchers hope forthcoming observations will reveal clues about its origins and the processes driving its bizarre behavior. Data from JWST, when combined with readings from observatories on Earth, provides a more comprehensive picture of a phenomenon that defies simple explanations. As interest grows, the public has become equally invested in the unfolding mystery. News articles, online forums, and scientific communities have been buzzing with speculation. Some people focus on the scientific aspects, marveling at the opportunity to witness an interstellar object undergoing rapid transformation. Others lean toward imaginative scenarios involving extraterrestrial engineering and hidden cosmic technologies. The presence of that puzzling nickel alloy, especially one known from human manufacturing, continues to fuel speculation and conspiracy theories. Even though scientists warn that more data is needed before drawing conclusions, the possibilities have captured global fascination. Meanwhile, amateur astronomers have pointed their own telescopes skyward, hoping to catch a glimpse of the enigmatic visitor. Because 3I/Atlas is relatively large, estimated at around 33 billion tons, it reflects more sunlight than smaller interstellar objects, making it somewhat easier to detect under the right conditions. Observers from multiple countries have reported seeing subtle changes in brightness and tail structure, though their equipment cannot compete with the clarity of professional observatories. Still, their observations contribute to the growing sense of collective curiosity that surrounds this rare astronomical event. As the object continues moving deeper into the inner solar system, scientists are preparing for an extended period of monitoring. They aim to determine whether the comet will continue behaving normally or exhibit yet another unexpected transformation. Could the anti-tail reappear once it moves farther from the sun? Will its trajectory shift in unusual ways? Will new substances emerge from its surface as it undergoes further thermal stress? These unanswered questions keep researchers engaged as they track the object's progress. What makes 3I/Atlas particularly intriguing is that it challenges assumptions about what interstellar objects should look like or how they should behave. Until recently, astronomers believed such bodies would generally resemble comets or asteroids formed in distant systems, following straightforward physical rules. But as more interstellar objects enter our observation range, each one seems to carry its own surprises, suggesting our understanding of the galaxy is still incomplete. The universe, vast and largely unexplored, may harbor materials, mechanisms, or even technologies beyond what humanity has imagined. For now, 3I/Atlas remains a celestial enigma, one that has transitioned from an anomaly with a backwards-pointing anti-tail to a seemingly ordinary comet with a sun-facing tail, all within a short span of time. Whether this transformation is the result of natural physics, unexpected chemical compositions, or something more speculative, the object has undeniably earned a place in astronomical history. Just like its predecessors Oumuamua and Borisov, it forces scientists to reconsider long-held assumptions and expand the boundaries of inquiry. As observations continue, the world watches and waits, eager to learn whether 3I/Atlas is simply a strange product of cosmic nature or a sign of something far more extraordinary journeying through the depths of space.